prove by mathematical induction that n cubed plus 11n is divisible by 3 for all n is positive integer. So for n is 1, it's the first possible value of n. In general, you may show that it's true for any n, but the easiest is to consider the first possible value of n. For n is 1, it becomes what? 1 cubed plus 11 times 1, which is 12, and it's clear that it is divisible by 3. So it's divisible by 3. Hence true for n is 1. Then, as usual, assume true for n is k, and it becomes k cubed plus 11k is divisible by 3. But how to represent it? We can represent it as 3 times some integer. Let it be m, for example, where m is positive integer. Since n is positive integer, so k is also positive integer. Then, as usual, we consider for n is k plus 1, and it becomes what? K plus 1 cubed plus 11 times k plus 1, and we need to show that it's also divisible by 3. Let's expand it firstly, and it becomes just binomial expansion. It's k cubed plus 3k squared times 1 plus 3k times 1 squared plus 1 cubed plus 11k plus 11. And as usual, we use this, and you can see that k cubed plus 11k is 3m. Or you may just write that k cubed is 3m minus 11k, then 11k just cancels. So it becomes 3m plus 3k squared plus 3k plus 1 plus 11, and is equal to 3m, and you can see that it's plus 12, and we can factor out 3. 3 multiplied by k squared plus k plus 4, and it's clear that it's 3 multiplied by integer, and it's also 3 multiplied by integers because k is integer. Hence we can conclude that is divisible by 3. And conclusion: if true for n is k, true for n is k plus 1. Since true for n is 1, true for any n is positive integer. And that's all for this question.